පේනවා ඇහෙනවා නේද ඔක්කොම? ආ පේනවනේ. මම ඔය ඉන්නේ ලස්සනට පේනවනේ. පේනවනේ මම මේ ඇති. Then right topic, the motion in a vertical circle. Motion in a vertical circle. Right. Yeah, we consider. Yeah, in a motion of the body. We attach the body, the string, and then we rotate in a vertical circle, right? I'll consider. So the small body of that mass is m, and we attach it to a string and then rotate in a vertical circle, right? So for side there, consider right there. Consider a body of mass simple m. Consider a body of mass simple m. Consider a body of mass simple m tied to a one end, tied to a one end of the string and of the string, tied to one end of the string and made to rotate in a vertical circle of radius r as shown in the figure. And made to rotate in a vertical circle of radius r as shown in the figure. As shown in the figure, right? Right, let simple u be the velocity of the body at its lowest position, and that means that here. Okay, let simple u be the velocity of the body at its lowest position. Right, its velocity for any angular position theta. Its velocity for any angular position theta is simple v. Is simple v. It's simple v. Okay, then can draw this first. Here, this is the circle of radius r. R means that the length of this string. That's r, the radius. You can see here. And this lowest position, that is L. M is the middle position and H is the highest position, right? The velocities corresponding to this point, we can find them. And this is a constant. So the point P I'm considering, which makes the theta is vertical. Angle theta with the vertical, right? So then downward, right? In the force acting on this body, you can write is the weight of the body and the tension of the string. Tension of the string is there, right? That's capital T I'm considering. at the reasonable position, we consider this one. Right, then you can resolve this mg just perpendicularly two directions. This is mg cos theta to this side because of this theta, and mg sin theta for this side. And in this case, you can see that weight is acted downward and this angle is changing. And then the centripetal force is given by the resultant of the tension and the component of that weight, that is mg cos theta, T minus mg cos theta. That is the force towards the center. So it's supply the centripetal force. But with the theta, the centripetal force is changing. Because of that, the velocity of its motion is changed by point to point. As at the lowest point, it has the highest velocity. We can approve that. And at the highest point, it has a lowest velocity. So let's see then. First you draw this one and then mark this off. And this lowest position, I'm considering this lowest position. This is the potential energy zero level, right? And the position at this angular position theta, this height we considered as simple h. That also we can find. H is the height. So you can write that height to the body from L2 from L, that at this reasonable position, consider that point P, height to the body from L, then at the lowest point, simple h you can write. At h, how can I write this simple h? From here to here, this r, and this point, this distance you can consider as that is r cos theta. Clear? This is cos theta is equals to this length divided by this r. So then there is r cos theta. And from O to L, it is r. So h then equals to the r minus r cos theta. Okay, then you can write h equals to r times 1 minus cos. Let's mark this all and write this. Let me know if you finished the writing. Raise your hand after you finish the writing, right? Are they? Right. All right, did bus. Then you can apply the energy conservation and can apply some the equation. So I will apply the energy conservation for this, right? From this point L to P and L point and P point. So then I applying mechanical energy conservation. Conservation. That's for L and point P. Okay. At the point L, this is the lowest I'm considered as potential energy zero level. So there's a kinetic energy that this point I given you that the speed or velocity is u here, right? You can mark it that this is u at the lowest point. Tangential speed is u. So then there is a kinetic energy at L. I'm writing the kinetic energy plus potential energy at L. That's equals to the kinetic energy plus potential energy at P. And here the kinetic energy is half m u square. Potential energy zero level. I'm taking in this position level, and at this point, this is kinetic energy is half m v square plus mg the h, right? In this m cancelled out, and you can multiply it by 2, right? M was cancelled. Multiply this by 2, then you can write u square equals v square plus 2gh, and then v square equals u square minus 2gh. Can get this equation. Question number 1. Let's see. And then, not equal number 1, h also we need to replace by this. Then v square equals u square minus 2g. The h equals r times 1 minus cos theta. So then v, you can write square root of v. That's the v. You can write the velocity at the point. So that's any reasonable point. At any point, you can get the velocity like. If you know the theta, then you can find the velocity at any position while it's moving in a vertical circle. Because of this vertical circle in moving, that with this angle, the centripetal force is changing. That means the speed is also changing. So it means the vertical circular motion is not a constant, that's a uniform circular motion, right? It's a variable uniform, that's a non-uniform circular motion. That's always the velocity and other components are changing. Right? Okay, then write the tension in the string. Tension in the string. We're using Newton's second law, you can get it, right? By Newton's second law. You can apply this towards the center. The force is tension minus mg cos theta positive. That's equals m p square over r. So the tension equals then mg cos theta plus m v square over r. Right after this point, then you can substitute this base cap from here. Potential. Are any? Then substitute v here. That's the value of v, that 3% mg cos theta plus MOR. That v you can write v square equals u square minus 2gr 1 minus cos theta. Right? 1 minus cos theta. You can simplify it, no? This t equals mg cos theta. You can multiply this. Mu square r minus, this is 2 mg, that this r cancel. That's 1 minus cos theta. This you can. Then this is mg cos theta. This is plus 2 mg cos theta. The total, there is 3 mg cos theta plus mu square over r minus 2 mg. So this is the second equation. The tension at any point at any position, angular position theta, you can write the tension in this way, and the velocity of the particle in this. Then by the angle, you can put that at the L lowest point, the theta equals 0. At this middle point, the theta equals 90 degrees. At highest point, the theta equals 180 degrees. You can put that theta values and get the particular tension and other values. So then we'll mark there, can write it to this point. I'll mark there the tension at this position. This is, let's say, TL. Tension at this position, let's say TM. And tension at this position, that is TH. The weight and tension is applied here down. Here the weight is down. And here weight is down. And the velocity is also, you can write this is Vm, the velocity at this position at the highest point. The velocity, let's say Vh like this. The different values. Then you can use in this particular angle, you can get the velocity and tension values for tension. Then let's see, we are going to finding, so is the condition to complete the circle, that's a more complete rotation without slacking the string, because we know that if the required velocity is not given in this position, it will not move into the complete circle. It goes up and then come back, or the string will be slack. So let's see how it happens. So you can write up to this point, and after finishing the write, let me know. Right. Then I will erase this, right? Tension equation and the velocity equation will be there. Now consider it, right? That's the first one. So theta equals 0. Then the cos 0, that's equals to 1. So then from equation number 1, you can write that's velocity at the lowest point. That is at 0, decreases at the L point. That's at x at L then. And then from first equation, the velocity is u, which you can here write. The cos 0, it's 1, then 1, 1, and this becomes 0. And this velocity, that's v become u then. And then from second equation, the tension is EL. The CL, it's become, we can substitute there. It's cos theta is 1. So then mg, the 2 mg, that will be minus, right? In the 3 mg minus 2 mg, that will be mg. Mg plus m u star r. Is the tension at this position. At the lowest point, you can write this. Then the second one I'm considering for theta equals 180 degrees. That's cos 180 equals minus 1. So that is right at the highest point. That's position. That is the highest position of the circle, right? Or highest position of the body or anyway. Body can reach the highest position is at H. All right, this is at H then. And then velocity you can write. That's VH. Taking that's cos, this is cos theta, cos 180, this is minus 1. So minus 1, it's become plus 1. So then 1 plus 1, 2. 2 into 2 is 4. So then the VH you can write then U star minus 4G R square root of this. Clear? Crystal clear. It is clear or crystal clear. And the tension at this position, CH, that's cos theta is minus 1. So then it is minus 3 mg minus 2 mg. That is minus 5 mg plus mu star R. So then I can make a condition to complete the circle, right? Right, to complete the circle without the string slack. So that means what happened there? This is the lowest tension at this point. The tension is the lowest at the highest point. The lowest tension of this string should not be equal to 0 actually, because if not, if this tension becomes 0, it's string slack there. So then condition is then the TS should be greater than or equal to 0. The equal case is that a minimum case, but it not be equal to 0. It will be always greater than to 0. Right? For a critical case, we consider that 0. So then you can write this TH already as a 5 mg plus m u square over r will be greater than or equal to 0. So then m cancel. So then u square greater than or equal 5gr. And then u should be greater than or equal square root of 5gr. So that means it should be greater than or equal to this value. At least the minimum value of the velocity at the lowest point should be equal to square root of 5gr. If this velocity is not given in this position, it will never cross this h point, the highest point. It will not complete the circle. It's clear. When we considering about as vertical roller coaster, it's moving like this. Before it's come to this circular path, it will goes to the much higher position and then come. And because they need to achieve this velocity at this lowest point, and then only they can move to this vertical position or they can complete the circle then. So it's very important. That should be the minimum height which the roller coaster should be sent to complete the circle. If that height is not sufficient, what happened then? Nothing to happen, right? Nothing to happen in the last journey in roller coaster, then, right? Here I am at the don't. Let's see the condition and then write up to this point. The u should be greater than or equal to 0. So from this point, you can say then that's the minimum u, then it should equal minimum should be equal to square root of 5gr. That is the minimum velocity at the lowest point should be equals to square root of 5gr to complete the circle without slacking the string. There are two things can happen then, because that velocity can be 0 before the string slack. If not, there's velocity remain there, but the string will slack. It's finished. Write and let me know. Oh, sorry. That's correct. To complete the circle without the string factor. Complete the circle without string like this. Because if the string is slack, it's not complete the circle. Then there's no force to force to make the centripetal force. Then it will not moving in a circle further. It leave the circle. If the string is slack. Clear? Clear කියලා සද්ද නැහැ නේද දැන් ඉතින් මම කරන්නේ. සරයක්. කොහොමද නම? නවත්තලා. හරියන්නේ. ළමයි කිසි විචාරයක් තියෙනවා. Right. Then right there, thus the minimum velocity required at lowest point or lowest position. Thus minimum velocity required at lowest position of the body. Lowest position of the body. Lowest position of the body. To complete the circle is square root of 5gr. Square root of 5gr. I'll erase this. Oh, sorry. I forgot this. Remember, v square, you can write that v square equals u square minus 4gr කියලා ඥාන. Main that's equation you can write as Roman number 1. මෙතන තිබ්බ equation මම මැකුව එක. Roman number 1, right? Okay, then write this equation, the TL equals mg plus mu square r. That's equals, to write this. This is Roman number 1, this is Roman number 2 again. So Roman number 2. Then write the corresponding tension in the string at the lowest position. Right, corresponding tension of the string at the lowest position. That's from this Roman number 1 you can write here, that is mg plus m for r. This u square, that's a minimum. For a minimum u, that is 5gr. Substitute the 5gr there. 5gr. The square root of 5gr, the u square, that's square of that. By squaring this 5gr to become, so then this r cancels, this 5g and mg plus, that is 6mg. This is the tension. That means at least this much of tension should be there because I am applying the minimum velocity there. So this is the minimum tension at the lowest point of the string. If at the lowest point, if it can achieve this 6mg tension, so it will not moving in a circle then again, right? So to complete this circle, there should be the 6mg times tension to this string at the lowest point. That means that's there with that strong string should be there. If it is a break at 3mg, like what's happened? It cannot be moving in circle. So then, and again, right, that's corresponding velocity at highest point. Highest point or highest position. That's H. What is that? That is a VH. It's from equation number Roman number 2. The VH you can write U square is 5GR minus 4GR. The square root of this. So then it's equals to the GR. This minimum velocity at the highest point. That's VH. That's VH minimum value at the highest point. That means to complete the circle, that should be the at least the lowest velocity should be square root of 5GR. Here it is square root of 2GR. The tension is 6 mg, and this portion has the tension should be greater than 0. These are these conditions, some conditions to complete the circle. Complete one circle that's without slacking the string. And when it is rotating, the most critical position at which the body can leave the circle is this highest point there. That critical velocity is the square root of 2GR. Okay, clear. Then I will write another one for third case. We'll say for that's for theta equals 90 degree. Then cos 90 equals 0. In this second equation, write T, the tension in this case is Tm. The cos theta, mg cos theta card is 0. So this is equals to m just our r only. And the velocity that's Vm is equals to the u square. So remember that's this is some taken from second equation. This still I'm taken from the first equation. Vm that's equals to the u square minus the 5GR minus 2GR. 5GR minus 2GR1 minus cos 90 degree. Square root of that. Cos 90 is 0. So then it is 3GR. And tension you can square root of tension is hardly on them more. Oh, here 3GR. It's okay, it's 5GR. Method tension negative. See. Tension. The first equation එක මම මේක second එක What is it? It will be mg cos theta plus mu square r minus this mg cos theta 2 mg cos theta 3 mg cos theta. This minus 3r. Okay, okay. The second equation. It will be that g m then equals that is 3 mg that's cos 0 cos 90 degree plus mu square r minus 2gr. Minus 2 mg ne? 2 sorry. මෙහෙම තමයි තිබුණා. මෙහෙම තමයි එන්නේ. හරි. මේක ස්වාතක 0 වෙනවා. This m for a u is square root of 5gr divided by r. This is minus 2mg. So this will become 5mg minus 2mg, that is 3mg. The tension should be 3mg at this position to complete the circle, and the velocity should be square root of 3gr, and it is square root of gr, and its tension should be greater than 0. Here 6mg, and this square root of 5gr. And here also we can show that same way this square root of 2gr. හරි ඔක දැන් එකම රටාවක් තියෙන්නේ ඔක්කොම ලියා ගන්න පුළුවන් ඔක අමාරු. Right, this is clear. Okay, I'll erase this all now. Okay now. Write this as a summary then. At this position, and this. Okay, summary we can write to complete the circle without hacking the string. This here should be 6mg, and this u should be square root of 5g. Clear? And then here, velocity should be equals to the Vm, that should be equals to the square root of 3g. Tension should be 3mg. And here th should be equal to 0. This velocity vh should be equal to the square root of gr. We can say at this point also, this t equals square root of 3mg. This equals square root of 3g. These are the conditions to be satisfied. That's a way. At this position, this velocities and tension should be there to complete the vertical circle without slacking the string. So you need to remember this. You don't need to keep remind those, but the way how get it, you can apply the energy conservation and the that's the Newton second law we can, right? This in make a ලියාගන්න summary එකක්. ඊට පස්සේ බලමු මේක මේ circle එක leave කරන්න සහ ඒක oscillatory motion එකක් හේතු කරන්න the conditions මොනවාද right? Okay, then write condition for oscillations. Condition for oscillation. Oscillation means here, product into condition. May question actually, good no here. What's the right there? First right, what is the required velocity at the lowest position? What is the velocity required at the lowest position? At the lowest position, just to reach the point M. Just to reach the point M. M means at the middle point. And from here, they're asking, this values are not there now. Now the different case I'm going to this part, right? These are not there. From this lowest point, let's say the velocity U they launched, and to just reach to this point, that means that this position the velocity should become 0 when you send it. So then using energy conservation, you can write energy conservation, you can write this half mu square at the lowest point. It's the energy potential energy 0 position. And then at this point is mg h means the r, the radius. So then m cancel. You can write the u minimum velocity should be equal then square root of 2g. So that means if you have given the velocity it's 2g, it's equals to 2gr, that's the object will reach to this point and then stop and then come back. So that's the condition then. This much of velocity should be given to reach the point M. It means, right? It means to, if your velocity given at this lowest point is less than this value, it will not come to this point M. If the velocity at this lowest point is greater than this value and less than the square root of 5gr, it will not come to this point, but it's past this point. Then when we are here, its string will slack. चलिए आगे you can write. Okay, after that, then you can write then the first thing, if that velocity at the lowest point is less than square root of 2g. Write a main carry the main. When u less than square root of 2g. Then what happen? That this velocity should be there to pass this point. And somewhere, let's say it's reached to this point, then at this point, this case, under this case is reached to this position. And then at somewhere here, the velocity becomes 0. The string means tension is there. But why this string cannot be slack? It's below the position M, because its weight is always down. So because the weight, to balance the weight, string should have the tension. The string never be slack below this point M. The string starts slack or slacking, and tension reduces when this region, when it is in this region, right? So it's somewhere here now. This mg, this height I'm considering as h now. I can find at what height it should be considered. It is less than this velocity. How we know that so if it is less than this velocity, it will never reach to this point m there. So what's happened then? Before it's come to the point m, its velocity becomes 0. So then it return that it retraces the previous path, and then it oscillates about the point L. මේක වටේ දෙපැත්තට මෙහෙම වෙන වෙන තියෙනවා. That's further motion is like that. Okay, මෙතනින් පස්සේ යන්න after this point. You can write there. In this case, the body cannot. In this case, the body cannot cross the position. In this case, body cannot cross the position capital M midpoint, right? Cannot cross the position capital M and thereafter return back. Thereafter return back towards initial position. Thereafter return back towards initial position. And due to inertia, cross the mean position L, cross the mean position capital L, and will oscillate about L, capital L, and will oscillate about capital A. So this is happened in this case. Then I the second one, when u is in between square root of 2gr and square root of 5gr. Okay, when this velocity is in between 2gr and 5gr. So that means it's past the point M, and but it not reached to the highest position, right? So the further motion, what happened? Before its velocity becomes 0, if they have the velocity, the tension of the string will become 0. So then there's no other process rather than the weight of the body. If the body is moving under the weights of it, so what's happened? The motion then it is a projectile motion, right? It will come like this. At this position, only the weight is there now. So we can find if that angle alpha is leave the circle. So we can find it what height it leave the circle. See that from here it's height h. It leave the circle. I will give you after that right there. Then under that right, as the velocity is greater than, square root of 2gr, as the velocity greater than square root of 2gr, the velocity that's u, right? The u is greater than this value 2gr. The body will cross the position capital M, that middle position. The body will cross the position capital M, but cannot go up to the position capital H. Cannot go up, but cannot go up to position capital H because u less than square root of 5gr. cos u less than square root 5t. So body will leave the circle. So body will leave the circle somewhere between P and H. Sorry, M and H, right? Leave the circle somewhere between capital M and H and will follow parabolic path. Will follow parabolic path. So hence the motion is a projectile motion. Look at the position where it's leave the circle, you can find then. At the position which body leaves the surface, leaves the circle. You can write in no tension. This is I'm taking as alpha, 90 minus alpha then. So the alpha, that is then mg sine alpha. That's the force towards the center. Only the weight is there. That should be equals to m discover r. This guy equals rg sine alpha. And using energy conservation, you can write use the energy conservation at the lowest point to this point. That's half m u square, that's equals to the half m v square plus mg r plus h. And the sine alpha, you can write h divided by r. You can write that sine alpha equals that h divided by r. Substituting the r, this equals to gh. So v is an equals square root of gh. If you know this h, you can write in this way, or h equal r sine alpha, then you can write. Let's cancel now. So I multiply it by 2, that is r plus 2g r plus h. The v square I can substitute from here, that's u square. Equals gh plus 2 gr plus 2gh. The total together, that's 3gh plus 2gr. And if someone given the some velocity is there, then they can ask what is the height it's leave the surface. Then using this equation, you can find the height. And then h equals u square minus 2gr. Let's divide by 3g. Simplify करेगा ना मम्मी निकाल. Do we have? Then pass on. I will write there. Then pass on back. Writing here, that means it should be equals to that 3 square over 3g minus 2r over 3. That should be the height where it's leave the surface, the circle. Then the may height can, it's not simple, that's simple h from the middle. Then in Amagato, you can add it at the r also there. So this is the velocity. If you know the h, you're going to find the velocity. So that means in this position, there's a velocity. That's why it's moving with the projectile, moving as projectile. If this velocity is 0, then it cannot be moved further. It will stop down as a motion under gravity. But it's come as a projectile because the tension 0, but there's a velocity. Okay. That's all thing about this. I'm gonna discuss this vertical circular motion only for the case is considering the string. But you need to keep in mind that we can apply this for all the cases. In the roller coaster is moving, the force acting on it, it should be the normal reaction, right? The normal reaction is applied on it to maintain the motion, right? You can think in that. මම ඔයාලට ගිය ටියුටෝරියල් එකක් දුන්නාද? අපේ විදිහට දුන්නා. Okay, okay, okay. හරිද? මොනවා හරි මෙතෙරික්ස් වෙනස් වෙනවා කියන්නේ. හරි නේද? ක්වෙස්චන් එකක් ලියාගන්න වෙන්නේ. Right, question. A nail is located okay, that's question, right? A nail. I think that's a nail is located nail is located certain distance. A nail is located certain distance vertically below the point of suspension. A nail is located certain distance vertically below the point of suspension. Vertically below the point of suspension of a simple pendulum. Of a simple pendulum. The pendulum bob is released. The pendulum bob is released. The pendulum bob is released from the position where the string makes the angle 60 degrees from the vertical. Angle 60 degrees from the vertical. Degrees from the vertical. Calculate the distance of the nail. Calculate the distance of the nail from the point of suspension. From the point of suspension, such that the bob will just perform. Such that the bob will just perform revolutions with the nail as the center. Revolution with the nail as the center. Assume the length of the pendulum to be 1 meter. So there's some nail there. nail එක වදිනාම nail එක වටේ තමයි ඊට පස්සේ කැරකෙන්නේ string. Right? So this is at the distance P. මේක මෙතන වැදුනහම that's path of its moving motion like this. And after this come from behind it, it's a nail, it's moving as another circle like this. motion after now. They are asking that what should be this distance be? Right, this is the nail. හොඳයි අහන්න. මේලා nail එක වැදුනට පස්සේ මේක සම්පූර්ණයෙන් කැරකිලා යන්න නම් what should be the distance d, right? දැන් බැරි වුණා නම් මම ෆොටෝ එකක් විදිහට දාන්න. ප්‍රොෆයිල් දාන්න. क्वेश्चन लिया गया बैठना ना मामा प्रूफ पे कर दे मामी स्क्रीनशॉट कर दे मामा how we can do the potential energy zero level. At this point, it's released, no velocity is released, right? And this is the length L, and this height, you can write then this is L minus, or length L minus this length. This is L cos 60. Cos 60 is half L minus L over 2, that's equals to the this L equals then H over 2. L over 2, sorry, H equals L over 2. Then apply the energy conservation. So energy conservation, then you can write there. That's a in this portion, there's no kinetic energy, so only the potential energy is there. That is mg, that length h is L over 2. That's only. And this lowest point, it has a kinetic energy. There half m. Let's say the velocity at this point is v square. The m cancel and half cancel. That's v equals square root of gl. And to complete the rotation or revolution, to just complete the revolution, the lowest velocity at this lowest point should be equals to square root of pi gr. Clear? Then you can equal it, right? Right, to perform a revolution, lowest velocity, the minimum velocity at the lowest point of the circle is that's square root of pi g. The r of this radius is equals to that. This is a d from here. That's L and the L minus d. This r radius is r. Then that's velocity at the lowest point velocity is this v, no? This v should be equals to then v equals square root of g r gl. That's pi g. R is then that is L minus d. Square root. And starring it, g cancel, and L equals pi L minus pi d. And pi d equals 4L, d equals 4L over 5. L is 1 meter, then 4 into 1 divided by 5. That is 0.8 meters. The nail is at the distance 0.8 meters from the suspension point. Okay, is it clear? Is it clear or not? Kung may lamang yun Okay. ඉවරයි නේද? අගන ඉවර නැහැ කියන්නේ. තවත් ක්වෙස්චන් ටිකක් කරන්න. ඔයාලට ක්වෙස්චන්ස් ටිකක් දැම්ම ඔය ගෲප් එකේ ඒක කරන් යන්න දෙක අපිට next week discuss කරන්න පුළුවන්. ගොඩක් ඔය ක්වෙස්චන්ස් කරන්න වැඩිපුර කැමති ෆිසිකල් පාර්ට්. තියරි කරාට ඔන්ලයින් ක්වෙස්චන්ස් ඩිස්කස් කරලා ඒව බලන්න. ජොලි කියලා දෙන එක තමයි වඩා හොඳ. හරි හරි තව ක්වෙස්චන් එකක් මෙහෙම ලියන්න. A small solid marble of mass simple m. A small solid marble of mass simple m and radius simple r. Small solid marble of mass simple m and radius simple r. Radius simple r rolls down along the loop track. Rolls down along the loop track without slipping. Loop track without slipping. Without slipping, right? Right. Find the height simple h. Find the height simple h. Above the base. Height simple h above the base. From where it has to start. From where it has to start. Start rolling down. Start rolling down. Rolling down the incline. Rolling down the incline such that the sphere just completes the vertical circular loop. Such that the sphere just completes the vertical circular loop of radius capital R. Radius capital R. Right? Okay, perfect. This what should be the height? This height to complete this vertical loop. I'll repeat: a small solid marble of mass simple m and radius simple r rolls down along the loop track without slipping. Find the height simple h above the base from where it has to start rolling down the incline, right? From where it has to start rolling down the incline such that the sphere just completes the vertical circular loop of radius capital R. This completes the vertical circular loop of radius R. Right? I get it.
Sir, can you repeat it, please?
Sorry?
Can you repeat it, sir?
Right? A small solid marble of mass employment and radius R or star along the loop track. එහෙම කිව්වම හරියට. I can a small
Sir,
solid
හිමීට
marble.
කියන්න, sir.
ඈ?
හිමීට කියන්නකෝ, sir.
හරි මුල ටික ලියාගත්තනේ without slipping කියන
ඔව්.
තැන එක ආයි ඒ ටික කියන්න ඕනේ නෑනේ.
නෑ, sir.
එතනින් පස්සේ ටිකද ඕනේ.
ඔව්, sir.
හරි. Find the height simple h above the base. Find the height simple h above the base from where it has to start rolling down. From where it has to start rolling down the incline, rolling down the incline such that the sphere just completes the vertical circular loop of radius r, capital R, right? Radius capital R, right? So it starts rolling down the incline such that the sphere just completes the vertical circular loop of radius capital R, right? And question again: the small solid marble of mass and capital M, simple M, and radius R rolls down along the loop track without slipping. Find the height h above the base from where it has to start rolling down the incline such that the sphere just completes the vertical circular loop of radius capital R.
Thank you, sir.
හරි හරි. Then thank you කියලා කිව්වට වැඩක් නෑ. හදන්න ඕනේ ඒක දැන් හරි. ලියාගෙන අත් දෙක පැදගෙන ඉඳලා හරියන්නේ නෑ. තුන් දෙනාම හදන්න ඕනේ. Then හදලා කියන්න බෑ ටක්කා. And I will give you the hint because it is rolling without slipping. That's the rotational kinetic energy is also there, right? Then you see where you go. Just then you can do it actually. Nothing to think about it, right? තව question එකක් එවනවා. ඒකත් දෙන්න හරි. questions කීපයක් කරමු දැන් මේකේ. lesson එක ඉවරයි. theoretical all things finished. දැන් හැදුවද? Then හැදුවේ නැති කවුරු? එහෙනම් බලන්න height, what is the height? No answer. තේරුණේ? Have any answer? දෙයක්වත් නැහැ. නිදිද? තුන් දෙනාම එකද? ඔක හදලා ඉවරයි මම අත්තා ක්වෙස්චන් එකක් එවුවා එකක් හදන්න. මොකද මම දැන් මේ තව ක්වෙස්චන් එකක් වත් දානවා. දැන් මේ තුනම දැන් හදනවා ඔක්කොම. දැන් දාපු ටික ටියුටෝරියල් එකේ එක දුන්නානේ මම ඒකෙත් ඇති. ඊට පස්සේ අපි ක්වෙස්චන්ස් ටිකක් හදලා let's start the hydrostatics. ඔන්න හදන් පටන් ගමු. Right. I just shared. I will send you the presentation regarding this hydrostatic lessons so that you can write the note. I'll explain it. It's better, නේ? එහෙම හොඳයිද? How can do this then? Let's see here. Initially, they have the kinetic energy. Let's know that at this lowest point to complete this circle, right? Complete the circle. That's the lowest point. The velocity should be there. That's minimum velocity should be there. That's 5gr, square root of 5gr, right? So to achieve this velocity, you can find that how much energy should be there, right? This using energy conservation, this mgh should be equals to the, at this point, it has a kinetic energy half m u square plus I omega square. Because it's coming withdrawing, so then there's a rotational kinetic energy also. This MGH, small sphere of solid sphere, that's marble. This mu square, there's a minimum velocity achieved, that's pi gr. Square of that is pi gr, right? And half the I should be that 2/5 m r square is a moment of inertia of a solid sphere. And omega you can write at this position. This omega will be, because it is rotating, moving in the circuit, vertical circle now. With the, you can write this omega should equals to u/r. So u equals r omega. That is u/r square of that. All right, another step, half m, that's pi gr plus half 2/5 m. Here the small r, because radius of the marble, this capital R is used as the radius of this circle. So u square is pi gr divided by, this is r square is there. U is square root of pi gr, the square is pi gr. 1 r cancel. M also cancel. H you can write in. This is pi g r over 2 divided by this g here. The side g is divide, half of cancel, and here pi g simple r square divided by this pi g r. So the g cancel. Maybe when g came to g capital. So g pi r over 2, that is again, here it is r square. This pi also pi cancel. The 2 also 2 cancel. R square over capital R only. So this is the height. Pi r over 2 plus simple r square over capital R. If it's come without rolling, just only sliding, this simple r, that part is 0, because no rotational kinetic energy, then it easily you can get it, right? If it's come with the slipping only, without rolling. Clear? Or not? හරිද තේරුණාද නැත්තම් කියන්න අය කියන්න ඒක නෑනේ සබ්බයක් නලානික වෙලා නිකන් අර මේ ළමයි නැද්ද? නෑ response. ඉතින් stuck වෙලා යා. Hello. ඉන්නවනේ. දැන් තමයි කෙනෙක් හරි ඉන්නවා. හරි. ඊළඟට දාලා තියෙන question එක බලන්න. ටියුටෝරියල් එකක් දාලා තියෙන එක මම print කරලා දෙන්නම්. ඔයගලන්ට ඔයගොල්ලෝ ගෙදරදී කරලා try කරන්න ඉතින් අපි ප්‍රශ්න ටික කරන් ඉන්නේ next එක discuss කරමු. මේකේ overall questions තියෙන full lesson එකේම තියෙනවා තියෙනවා. ඒකට අපිට දැන් next එක ඔයගලන්ට term test උත් තියෙන හින්දා ඒ ටික linear motions උත් කීපයක් තියෙනවා. ඒ ටික ටිකක් කීපයක් discuss කරාම පොඩ්ඩක් මුල ඉඳන් අගටම lesson එක මොනවද තියෙන්නේ කියලා පොඩ්ඩක් revision එකක් වගේ කරන්න පුළුවන් ඒක. හරි ඒක try කරලා ඉන්න ඒකට ලේසි නැත්තම් ඒ වෙලාවේ කරන්න වෙලාදීදී කරන්න කිව්වොත් වෙලා යනවානේ. ඊට පස්සේ මේ ඊට පස්සේ දීලා තියෙන question එක කරන්න. The steel balls A and B have a mass of 500 gram each and are rotating about the vertical axis with an angular velocity of 4 radians per second at a distance of 15 centimeters from the axis. The collar C is now forced down until the balls are at the distance of 5 centimeters from the axis. How much work must be done to move the collar down? It's tell me that's what's the principle which you are going to use for this one. Just remember, tell me. What's happened then if you force the collar down? What's happened? That's the way you have to enter to the equation. All right. I'll come with it, right? Then if you force the collar down, what's happened? The radius, its radius means that the angular, that's the moment of inertia is reduced. So then you can apply the angular momentum conservation because there is no any torque you apply to there, right? You force this down, it's vertically downward, but there is no any torque applied about the axis of rotation. Then you can apply the momentum, angular momentum conservation. Right, so then in angular momentum, according to the angular momentum conservation, if the moment of inertia now decreases, if the moment of inertia decreases, then angular velocity increases. Right, so then the kinetic energy, that's the rotational kinetic energy increase. So that increase in rotational kinetic energy, that's the difference of the rotational kinetic energy before and after. It should be equal to the work done to force the collar down. That's the theory. You can write this if you couldn't understand this in the let first write there. That's when the color goes down, this angular momentum is changed. Sorry, this angular momentum should be keep constant, but as the momentum of inertia is reduced, so the rotational kinetic energy or the angular velocity will increase, and then the difference in kinetic energy, rotational kinetic energy, just equals to the angular. Sorry, that's they're asking the work done. Okay, just try to the answer, follow the way I have given you. Okay. Let's see how to solve this, right? In raise this one. Okay, now there are two marbles of the mass 500 grams. Given. Billboards and we have a mass of 500 grams. Each are rotating about the vertical axis. Way like this, right? So the angular velocity is given. Rotating angular velocity, that's 4 radians per second. This color this down. We will close. Now let's see the omega is the angular momentum. And in this case, the initial moment of inertia, the moment of inertia is mr square. So there are two balls, then two mr square. Consider this as a particle, which is rotating. It's at the distance 15 centimeter here. Then in this case, it's a 5 centimeter here. So this I1 equals that's 2 into the 500 grams 0.5 into R the square, that is 0.15 square. Given the radius, distance. So this is 1 and 0.15 square of 1.5 is 225 is 0.225 kilograms per meter. Omega 1 is so useful now, that's 4 radians per second. And in this case, I2, that's 2 into, that's mr square, that's 2 into, that's mass is 0.5 and R square is 0.05 square, because it's 5 centimeters. So then squaring this 0.0025 kilograms per meter. And then omega 2, you can write this using angular momentum conservation, that's I1 omega 1, that's equal to I2 omega 2. I1 is 0.0225, omega is 4, and I2 is 0.0025, and this omega 2. Then omega 2 you can find, that is 1 to 25, this 25, this 9 into 436 radians per second. Now this work done, that's equals to the change in kinetic energy. The final kinetic energy half I omega square. The I already know that is this 0 point. That's I'm writing this 2.5 into 10 to the minus 3. This I1 omega I2 actually I2 omega 2 square minus half I1 omega 1 square. It's work done. I don't have enough space to have right here, right? Theoretically, one meter Indiana, the Queen Indiana. So work done, right? Half. That's 2.5 into 10 to the minus 3 omega 1. This omega 2 is 36 square minus half into 1, 2, 3. 22.5 into 10 to the minus 3 into 4 square. Clear? The change in energy that's equals to this work done, because there's nothing the energy to happen. That is 1.44 joule. 1.44 joules. හරි ලියන් ඉවර නම් කියන්න කොහෙන්ද ඔපරේෂන්ස් දෙක තුනක් කතා කරන්න ඕනේ okay here I have a question another question right here important one but yeah I know because that question I have the soft copy one it is in signal that's all right you can write there then write there write the expression the part one of the question right part one write an expression for the the power delivered to a body or delivered to a body which having right an expression for the power delivered to a body having angular velocity about an axis angular velocity about an axis angular velocity about an axis using the equation in linear motion using the equation that right as power equals force into velocity using the equation that's power equals force into velocity in linear motion right and linear motion and introduce the symbol you use or you can write the name the symbols you use using this equation you have to get the expression for the power in angular motion so you have to use that some symbols you use let's say that if you want to use a moment of inertia then you can write as I equal moment of inertia like that you can name the symbols you use okay this is the first part right? Then the part this part B right there then write the water wheel is rotated the water wheel is rotated by the water flowing through a canal by the water flowing through a canal and it is connected to a it is connected to an electric generator is connected to an electric generator the radius of the connected to an electric generator right this is the generator this is the water wheel then right the radius of the water wheel is 5 meters 0.5 meters kind of wheel is there. And the canal, like water. The water will hit on him, and then this will rotate. We rotate in the maybe. It's rotating with the angular velocity 6 radians per second. That is radius they given as 0.5 meter. So it is connected to this generator by a string. Clear? And then right. The water flows towards the wheel with 4.2 meters per second. With the speed of 4.2 meters per second, water flows towards the wheel with the speed 4.2 meters per second and the water exit with the velocity or with the speed, and the water exit with the speed 1.8 meters per second. The water come towards them with 4.2 meters per second, and after the rain, it's leave or it exits with a 1.8 meters per second. It's clear, right? Then the wheel rotates with an angular velocity 6 radians per second. Right, then the wheel rotates with an angular velocity, with a uniform angular velocity, correct? With a uniform angular velocity 6 radians per second. 6 radians per second. The rate of water flow, right? The rate of water flow is 850 kilograms per second. This much of rate the water flowing there. That's per second. 850 kilograms are flowing through it. Then write the first Roman number 1. Calculate the rate of change in momentum of the water. Calculate the rate of change of momentum of water passing through the wheel. Second one, second part. Hence, find the torque acting on the wheel. Let's find the torque acting on the wheel. Third one. What is the power divided by the V? Fourth part. Okay, you can write up to this point because I don't have enough space to write there. Fourth part I had to read till the another explanation and they need to write there. Then write. This power is transmitted. This power is transmitted to the generator. This power is transmitted to the generator by by a tight belt which is passing through this is passing around here. This is passing around a pulley passing around pulley of radius 0.4 meters on the axis of the water wheel. 0.4 meters radius, 0.4 meters on the axis of the wheel, and another pulley of radius, 0.02 meters, 0.02 meters on the axis of the generator. I'll draw the separate diagram for that part. මේ කියන්නේ දැන් මේක එහෙම wheel එක තිබ්බට cable එක මේකේ කෙලවරෙන්ම ගහන්න බෑනේ. ඒකට මම මේක මෙහෙම ඇඳලා cable එක තියෙන්නේ හරි මේක axis එකේ මෙහෙම මැද හරි. කොහොම තමයි තියෙන්නේ කියලා. මේක මැදින් එන්නේ කොහොම? ඒක මම වෙනම මෙතන අඳින්න වගේ wheel දෙකක් තියෙනවා. This is 0.4 meter. This is 0.02 meter. This is on the generator axis. This is on the axis on the wheel. Right. This point. This will rotate with the radians 6 radians per second because this is on the axis of the wheel. So these 2 points I'm considering as A and B. Here. This is AB and this CD. Points are can draw this diagram. Then first part of that make it so when the wheel rotates with 6 radians per second, when the wheel rotates with an angular velocity when the wheel, that means the water wheel, rotates with angular velocity 6 radians per second. 6 radians per second. What is the angular velocity of the generator? What is the angular velocity of the generator? Right? And then second part, that's the last part, right? The tension on the string or belt, tension on the belt, tension of the belt between A and B, tension on the belt between A and B is 50 Newton. They given this one, right? So last line means which one? This one or this one? Which one?
Second answer.
මේක නේද?
ඔව් සර්.
The tension on the belt, between A and B is 50 Newton. This one, right? මේක ඇඳලා තියෙන රූප. A and B is 50 Newton. Find the tension between C and D. Find the tension between C and D, point C and D. Okay. Now try to this related to this angular motion. Say type question. Term test. වලට ඔය වගේ ප්‍රශ්න තමයි දෙන්නේ වෙන්නේ. හරි. ඉතින් ඔක ලියලා ප්‍රැක්ටිස් කරන හොඳයි වගේ. ටෙස්ට් කියනවා ලබන සතියේදී. හරිද අපි බලමු දෙන්නේ පැහැදිලි නේද බලන්න දන්නේ නැත්නම් ඒ කරන්නේ let's see how to do it first part. That's given that the symbol I use that power is P and the force V. The force that's V you can write it is equal to R omega. That's F into R is omega. So the FR you can write as tau omega. So then the power you can write given by the torque. So that is tau omega. The tau is the torque and omega is angular velocity. And P is the power. Then using this equation you can get the power tau omega. So that is in a rotational motion. The power, right? This first part. Now to part B, they're asking the rate of change of the momentum. The water will flow with the 4.2 meters per second and leaves 1.8 meters per second. Right? So then the rate of change in the momentum, that's equals to the that's theta mv by delta t. Then you can write the delta m over delta is the mass flow rate, and then it's v minus u, the velocity change. The mass will flow with the rate 850 and velocity change is 4.2 minus 1.8. So this is 2.4 multiplied by 850. That's 2.4 into 850. That is 2040. This is actually the rate of change of the momentum is Newton force. That's all right. It's Newton because the rate of change of the momentum is Newton. That's force. First part. And then second part. The torque they're asking. The torque equals F into R. This water hits on the wheel at the distance 0.5 meter because at that edge, that's the radius of that. So then it is 240 multiplied by 0.5 meter. So this is 1020 Newton meter. That is the torque. Right? 1020. And then they are asking the power. Okay, give me a second. Okay. And then the power they're asking, that's the equation you derived above. This you can use to calculate the power, that is torque into omega. The torque is 1020, omega is 6. Then you multiply this by 6, that is 6120 watts. 6120 watts power is delivered. Okay. Now this belt is connected with the 0.4 meter pulley and the 0.02 meter radius pulley. So when this rotate and this also rotate, then the omega, let's see the angular velocity. So but the same belt they use to rotate it, right? So if you consider about that's a tangential speed of a particle, it moving is the same for this wheel and this wheel both, because that belt is moving with the same speed, right? So it's a tangential speed, so you can write in for the large wheel is its radius, that's r into omega 1, let's see, and other one is r2 into omega 2. The smaller one and larger one. This r1, here the r1 is 0.4, omega is 6. The r2 is 0.02, and omega 2 you need to find. Then you can write. That is 4 and 40, that's 120 radians per second. The fourth concept. And then the first step. And the second, the tension. This one is given as tension T1 is 50. Asking the tension, CD can right? Tension on this curve. This is different tension. At the power, here the power, you know that, right? The same power delivered to the generator also. So the power of the generator, then generator is generator is same as this 6120 watts. So its power equals to the torque omega. Its power is 6120. The torque is for the generator wheel, the torque is that is T2 minus T1 multiplied by the radius 0.02 multiplied by the omega is 120. So omega you already find. So then you can simplify 120, that's 100. Can divide it by 0.02. This is then that's T2 minus T1, then equals to the 5,100 divided by 2, that is 2,550. So T1 is 50 Newton. Now T2 is T1 plus 200, 2,550. So that's all together. That is 50, now it's 200, 2,600 Newton. This is the tension of the string between C and D. Right, that's all. Is it clear or not? Could you understand or not? You can let me know then. I can explain. If you want, I can explain again. If not, we go through the next question. Harida, can I erase the board? We'll discuss the question I'll send you, then we'll stop the class after that point. And again. ලියාගත්තද නැත්නම් තාම ලියනවද නැත්නම් තේරිච්ච නැති පැනක් තියනවද? හැපුතා. හරිද? මකන්න. All right. හරි අනිත් ක්වෙස්චන් එකක් බලන්න. මම PDF එකක් දාලා This another essay type question. You can read it and then having that's the question. First, I read you. You can go with me, and then we'll do together. We'll do right. And in electric power generation, the frequency of output voltage depends on the number of magnetic poles, capital P, and the number of revolutions per minute, capital N, of the generator. The frequency of hertz in hertz is given by as F equals P into N over 120. That is, frequency is given by in hertz, right? That's N is the revolutions per minute, is capital I. A portable generator consisting of two magnet poles typically works at 3000 revolutions per minute. That's RPM given. Find the following. First one, they are asking the frequency of the output voltage of the generator. Second, rotational speed of the generator in radians per second. How you can find the frequency? It is easy. That's the equation they given. You need to substitute it. That given that the portable generator consists of two magnetic poles. That's the equation they given. This is frequency is P into N 120 divided by 100. So there are two poles. P is the number of poles. There are two magnetic poles, and N they given as that's revolutions per minute. That is 3000 revolutions per minute. That's you can substitute it 3000. No need to convert it to the other units because this N is given in 3000 revolutions per minute, and N is in revolutions per minutes divided by 120 days. So 6000 is 50, no? That is 50 hertz. The second they ask in the angular velocity, radians per second, rotational speed, then omega, that is equals to phi f. The phi they given as 3 is 50. Now we can multiply this 300 radians per second. Right. That's plus 2. That's the part B there. Let's again we read the passage, and they given the figure. You can get an idea. When the water is flowing through this flow tube, and there's a pedal, there's a throttle valve is there. That's still when the water is flowing. They can control this throttle valve, and then this fly balls will get separate or moving. The spring is also connected to the other fixed spring clamp is there. That's pivoting point in the left CPR, right? Okay. Read it. A student has designed a model of a hydropower plant by replacing the engine of the portable generator mentioned in A above with the turbine that can be rotated by a water flow. He observed that the frequency of the output voltage varies with the consumption of electricity even at a constant water flow. To control the frequency variation of the output, he designed a controlling device to adjust the water flow to the turbine. Schematic diagram of the controlling device connected to a throttle valve is shown in the figure there. Then the question, assuming all joints in this device are free to move without friction. During the rotation, fly balls move horizontally, and it makes the sleeve move up and down along the rotating axle. This device is symmetric about the rotating axle. The opening and closing of the throttle valve is automatically controlled by the rotational speed of the turbine. All the other parts of the device can be assumed to be massless except the fireballs. Right. First part. Draw the free body force diagram for a fly ball, assuming each arm connected to it is under the tension. Consider the mass of the fly ball to be M. Simple M they give back. It's 2 parts. Salam Amige. Three word diagram calling with figure. ඉස්සල මම අර කළා වගේ එකක් මේකේ. මේකේ තියෙනවා ස්ප්‍රින්ග් එක. මේ ටික විතරයි අපිට ඉතුරු වෙන්නේ නැති වෙලා. හරි. කොහොමද තියෙන්නේ? In this length ඒවා ගියලා දෙනවා අපි අපස්සවල. Then the past one free body diagram. This is a ply ball. Okay, this side, let's say it's tension T1, and this downside is tension T2, and then the weight mg. Those are all the forces acting on it. This is a free body diagram for that, right? This is a free body diagram for a fly ball. And then if the angular velocity of each fly ball about the rotational axis is omega radians per second, show that the tensions in the upper and lower arms are respectively given by this upper and lower arms, right? L is the length of the each arm and H is the height of the each fly ball from the lower clamp. So this side is given as H, this rod is L, and I will take this angle is theta. Then you can see that sin theta or cos theta equals H over L, and then H equals L cos theta. Okay, right in this is an equilibrium case. I'll use forces acting upward, that's equals to downward, that's C1. So cos theta, that's equals, that's minus T2 cos theta. That's T2. This is also theta because there's a alternate angle. This theta, this also theta, is symmetric. T1 cos theta, T2 cos theta, that's equals to weight of the rotor. That's right. That's T1 minus T2. That's equals mg divided by cos theta. And then apply F equal ma to a center because it's rotating now. So you can write then it's T1 sin theta plus T2 sin theta. That equals to the m. The radius, this radius is simple r, mr omega square. That's angular, that's a centripetal acceleration r omega square. Simple r also you can write that is r equals L sin theta. That's then T1 plus T2 sin theta equals mr we can write as L sin theta omega square. The sin theta cancel. T1 plus T2 that's equals ml omega square. According to this equation, you can write the cos theta equals H over L. And in here, you can substitute it and write mg cos theta equals H over L, then mg L over H. Cos theta you substitute, this is the first equation you have, this is second one. Then add first one to second one. Then T1 minus T2, T1 plus T2. T2 cancel this 2T1, that's equals to the mg L over H. I'll write this L omega square, second one, plus mg L over H. And then T1 equals, take this M L and this 2 also divide this side by 2. And in here it's omega square plus here is G over H. So this is the tension in the upper arm. So that's the given expression will come, right? And similarly, you can find this 1 minus 2. This gives you the T1 cancel and T. So there's 2 minus 1, let's see. Here the T2 is equal to T2. And it's ML omega square minus mg L over H. So then T2 equals ML over 2 you can take out omega square minus T over H. So these are the two expressions they ask you to. Clear? Okay, if you finish right, let me know. I have erased the board, then go to the next part. Okay, I will erase this one, right? Then third part, they're asking when the frequency of the output voltage is 50 hertz, the value of H is 30 centimeters. Value of H is 30, that's all that the distribution to the tension from the term G of H can be neglected. So I will erase this part. Then at 50 hertz, the omega square is that 300 square, that is 90,000. Right? The omega square value is 90. And then G of H, G is 10, H is 30 centimeters, 10 to the minus 2. And it's so simplifying this 1000 divided by 30, 33.33. So therefore, the G of H is very smaller than this omega square. So we can write then the G plus H can be negative. And we neglected. That means the T1 you can write approximately equals to the ML omega square over 2. And the T2 also you can write as it's approximately because it's also neglected. ML omega square over 2. T1 T2 then equals because in considering this as neglected. And part 4, the mass is given and L given, calculate the tension in the upper arm. This equation you can use it. Upper arm or lower arm if the G is neglected, so nothing different. T1 as mass is 1, L length is 0.5 because it's 50 centimeters they given, right? 0.5 meters, omega is 300 square divided by 2. That's 90,000 divided by 4, that is 2,000, sorry, 22,500 Newton. When the frequency of the output voltage is 50 hertz, the contraction of the spring is 50, that's 20 centimeters. Spring constant of the. Now I'm considering this part, right? Let's, if there's a force like this, there should be the force on the spring like that. So then you can write Fp equals, this is also T, that's tension is T1, let's say. And this side also T1 because there's symmetry. So then you can write that's 2T1 cos theta. That's equals 2T1 cos theta. That Fp is a force on the spring. So that's equals to the K into X. The T also calculated out. This 2T1. This cos theta is H over L. Then Kx. K equals then 2T1 H over Lx. So 22,500. H is 0.3 and L is 0.5. X is 0.2. We given the contraction. X means that's a contraction here. You can find the value of K then. That's 0.5, 0.2, it is 0.1 and 3, here 3, 45,000 into 2, 1,35,000. Newtons per meter. The spring constant. Hi. This is then the part C, the last part. Then they given when the frequency of the output voltage is 50 hertz, the throttle valve is set to block 50% of the flow. That is, the valve is making an angle at making an angle of 45 degrees with the axis of the flow tube as shown in the figure 2. They given there. Assume that the forcing of the throttle valve is proportional to the angle of the valve with the axis of the tube. Frequency of the output voltage depends on the consumption of electricity. When the consumption increases, the output frequency decreases, as vice versa. Consumption increases, the output frequency decreases. According to the design, when the frequency of the output voltage becomes 25 hertz, the throttle valve will be fully open. It's fully open, right? The valve will remain. That fully open means that is 0% block. That's 50% block is 45 degrees. Now 0% block is for 25 hertz. 0% means that's it's a parallel again. Sorry, completely close. Sorry, parallel තියෙන කියන්නේ. flow එකට parallel. එහෙම යනවා නම් මෙහෙම value එක කොහොමද තියෙන්නේ? 0% කියන්නේ block 0. 45% කියන්නේ මෙහෙම හැරෙයි. 90% නම් මේ කියන්නේ. 50 100% කියන්නේ එයා close වෙනවා. ඒක තමයි ඒක කියන්නේ. The valve will remain fully open even for frequencies lower than 25 hertz. Can 25 volt අඩු frequencies වලත් තියෙන්නම යා fully open වෙනවා. එතනින් එහාට වෙනසක් වෙනවා. Determine the following and instead of the opening that neglect the contribution of the term C. The tension of an upper arm spring. Let's now the omega is not the constant here, right? Right? The omega is not 300 then. Because now 25 hertz. That's omega you need to find again. So omega equals then 2 pi into F. That's 2 into 3 into, that's 25 now. Previously it's 50. Now it's 150 radians per second. Now the omega. Now the tension you can write now. Tension, the T dash, the different value of this omega, M, L omega square over 2. That's M is 1 kilogram, L is 0.5. And omega square is 150 square divided by 2. 150 square is, that is 22,500. 2 lakhs to 25,000. Divided by 4 it is. And this is 22,500 divided by 2, that again divide by 2, that's 4. That's 5,625 Newton. 22,500 divided by 4. So this is the tension there. Second part. The contraction of this spring, they ask now. Contraction of this spring. Now, it's little different, right? Here I'm given. So before come to this point, they previously this is H and this is H. H is given as 30 centimeters previous case. And then 2H. Then you can write the original length of the spring. Original length of the spring. That is now this length is 60 centimeters plus the 20. 20 is the contraction they given at that point. So 60 H to 30 when we contraction negative 20 in the. So then 60 plus 20, that is 80 centimeter is the natural length of the spring. In this case, you can find this H will be changed now. Your total like for iron, so the H dash and H dash less. Because now the tension is also a different value. And then you can find what is the force acting on this. That's not the force is also then tension වෙනස් වෙන හින්දා මෙතන දෙන force එක වෙනස් වෙනවා. Let's say dash less T1 dash T1 dash. This angle also changing. That let's different variable and then let's say what's the alpha. Now මොදිබා මේකන H උත් වෙනස් දැන්. L is same. L is a rod. මේක මෙහෙම පොඩ්ඩක් මෙහෙම ඇදෙනවා මෙහෙට හරි මෙහෙට හරි යනවා. Clear? එතකොට දැන් එතන H dash හරි මොකක් හරි කියලා හිතමු. So then in here you can write as F dash equals to T1 dash cos the alpha 1. Alpha 1 cos alpha 1 equals to the cos alpha equals to the that H dash divided by the length L. Give me a second, please. Right. This the cos alpha you can write in this way, that is H dash is a new height. When I say now, F dash you can write then 2 T1 dash into H dash over L. And this F dash you can write that is a spring constant and new contraction. That's the contraction of the spring. So F equals kx. But you don't know this H dash. How can I find H dash? With H dash හොයාගන්න පුළුවන්. දැන් මේක contract වෙලා තියෙනවනේ ප්‍රමාණය. And previously the original length is 80 centimeters. So අපිට ලියන්න පුළුවන් මේකේ 80 minus 2h dash. Original length එකෙන් මේ දැන් තියෙන h dash වගේ දෙකක් එනවනේ මේ මෙහෙම දෙපැත්තට. මේ length එක අඩු කරාම it is equals to the contraction x. X dash කියලා දාන්න then now new one. So then h dash you can write as මේක දැන් ලියන්න පුළුවන්. That is 80 minus x dash divided by 2. You can substitute it here. And then you can find x dash within this equation. That's 2 e1 dash. H dash is at 80 minus x dash divided by 2 by L kx dash. Solve this for kx. Then you can write x. When it's substitute 2 into 5625, L is 0.5. And you can make 40 minus x dash over 2. Then 1.35 into 10 to the is equals to the 1.35 into 10 to the 4. Plus of this million into x dash. So they can get it answer මෙතන 11 250 22500 22500 1,35,600 නේද 22500 45,000 දෙකයි 6. ඒතර මෙතන සිම්ප්ලයි කරාම එන්නේ දැන් ලියන ඊට මත 40 minus 6 over x dash 2 that's equals to the 6x dash. So when taking medical 12, 13, 8. So x dash equals 80 divided by 30. That's 6.15 centimeters. The new contraction is 6.15. ඒක සුළු කරන්න මේ මම ලියලා තිබ්බ එකේ සබ්ස්ටිටියුට් කරන්න තියෙන ඔක්කොම වැලියුස් දීලා තියෙනවා. මේක තේරුම් නැත්නම් කියලායි කියලා දෙන්න. දැන් තේරුම් නැත්නම් කියලා දෙන්න මම කන කලින් මොකද මේකේ තව එක කොටසයි තියෙන්නේ. question එකේ ඊට පස්සේ අපි මේ ක්ලාස් එකේ අදට නවත්තනවා. මම අස්නේ කරලා ඉවර කරන්න ඕනේ ඉඳ මම මේ ඊටම කරුවා. හරිද? now final part එකට යන්න. got the last one. When the frequency of the output voltage increases, the throttle valve causes gradually to decrease the flow rate. If the flow is to be blocked by 75%, what should be the frequency of the output voltage? There is no any proportional relation එකක් නැහැ මේ. Because initially that's when the 25 hertz තියෙද්දි ඔක 0 open ඊට පස්සේ දිගටම 25 hertz ම තමයි තියෙන්නේ කියලා කියන්නේ. කියන්නේ ඒක open වෙලා ඊට වඩා අඩු වුණත් එයා 0 ඒ විදිහටමයි තියෙන්නේ. ඕකේ එහෙමනේ දීලා තිබ්බේ. ඔව්. ඒ ඉඳලා මේ 0 වල ඉඳන් එන එකක් නෙමෙයි තියෙන්නේ. හරි. And you can write this is that if the block is 0%, the frequency is 25 hertz. If the block is 50%, this is 50 hertz. That means when the block increase by 50%, for a 50% of block increase, the frequency increase by 25 hertz. Right? That initial, this is the increased one. That initial one is 25 hertz there. Then 25 hertz, මෙච්චරක් එකතු වෙලා that's 50% block. Write it again. They are asking this what is for 75, right? So increase the 50 increase, right? For the 50% block increase, the frequency increased by 25 hertz. And then you can find what is the 75% increase. That's the delta frequency. The delta if you can find it. How much the frequency increase for 75% of block? For 50% block is increased by 25 hertz. This is from 25 to 50, 25 increase. Now we can, this is 2 and 25 or 3, that is 75 divided by 2, that 37.5. Hertz is increased. That's the frequency increased by 37.5 by what? Now new frequency is then initially there's a 25 hertz because at a 0 block is 25 hertz is there. So now the frequency is 25 plus this increased amount. The total together is 62.5 hertz. හරි එහෙම නැත්නම් ඔයාලට පුළුවන් මෙතනින් තව වෙන විදිහකට ගන්න. දැන් 0 to 50 25 to 50 hertz. මෙතන මෙතනට 25 increase වෙනවා 25 increase වෙනවා මේකෙන් භාගයයි. ඒ කියන්නේ 12.5 තමයි වැඩි වෙලා තියෙන්නේ. ඒ කියන්නේ 50 වලින් 12.5 වැඩි වෙනාම 62.5 hertz කියලා නිකන් just දාන්න පුළුවන්. අර ඒ proportionally ඔකේ කියලා තියෙනවා නේ ඒ විදිහට වැඩි වෙනවා කියලා. Okay, I think it's clear. So this question is that is 2019 A-level essay question paper එකේ first question එක කියන්නේ හරි. Okay, පෙච්චර අමාරු එකක් නේ. ඔයගොල්ලෝ එකයි try කරන්න ගෙදර ගන්න. වීඩියෝ එක share කරන්න. හරි නේද? තව මොනවා හරි ප්‍රශ්න තියෙනවා නම් අහන්න නැත්නම් ලියාගෙන ඉවර නම් you can leave. Goodbye. God bless and take care. Next we'll do revision for this all and you will you can come with the questions you have, then I can explain more.
Thank you, sir. God bless you.
Okay, God bless and good night.